All right, we're starting out in here because the test is Wednesday, and if there are any questions. PJ, I believe you have some questions.
Yes. So it would be master set 26.
Okay.
It would be number 3.
The two thin plates?
Yes. I didn't have issues on A or B.
Okay.
My problem started, actually, I technically didn't really understand B. Like A was fine. B is, I used the formula delta V equals negative E dot delta S.
Okay.
Is that the correct formula for that?
Yep.
Would E just equal case of EQ over R squared in that problem?
No, that's the point charge formula. We have the parallel plates, so the electric field, magnitude of the electric field is sigma over epsilon, or not, or is, I don't think there's a dielectric in there. But that's what you'd use for E. What'd you get for the voltage?
For
A, what'd you get for A?
Negative 271 volts.
You said negative 200 and what?
71.
Did I change numbers on this, or is there a 30, 0.5 by 0.5? How do you get that?
Or would it be 135?
Yeah. You're going from positive to negative, so it would be negative.
Oh yeah, I did a calculator here.
Ah.
I had everything right now.
Okay.
But I understood the gist of it.
Yeah.
I think I put in 30 twice.
Ah, that would do it.
So in terms of electric field for B,
Right.
what formula are we using to find the electric field?
The one that you said is right, just that your electric field is sigma over epsilon sub naught. And then times the distance from the negative plate to halfway.
Are we given? How do we find the sigma?
You were told the charge and the area. So sigma is the surface charge density, so sigma is just the charge over area. Okay, how did you solve A? Because I found this as part of my solving for part A.
For A, I started with C equals Q over V, and then that equals epsilon sigma A over G. And then I solved for V, so V was equal to Q D over epsilon sigma.
Ah, okay. So if you play around with that, if I bring area down and voltage up, I get Q over A. Actually, Q over A epsilon naught is equal to delta V over D. Q over A is sigma. So I get sigma over epsilon naught is delta V over D, ignoring signs. That's my electric field. So
what makes it negative? The final voltage.
because you're going from positive to negative. The positive plate is the higher potential than the negative plate, so It all depends on what direction you're going in. Okay. So PJ, what you did for A is fine, it's just,
Math error.
yeah, other than the math error.
B was, I did write Q over A equals sigma, but I crossed it out because I didn't really know how to relate it.
Okay.
For some reason. And then C, that was fine. Let's see. 4A, or 4B, I have issues with sketching the graph with the dielectric. I assume the inside electric field is 0, so it should be constant.
It's a charged dielectric. The dielectric is an insulator. So the electric field is not going to be 0 inside. If it's a conductor, then excess charge within the outside electric field is in the middle is 0. So number 5, the electric field is 0 inside.
So
the graph, the electric field, I know in the middle is 0. So if that's the radius, this is little r. And here's my electric field. Outside of it, it's a 1 over r squared relationship. And then whatever the value is at the surface, and then it's linear. So that's my electric field. I know that E is negative dV dr if there's only a dependence on r. R hat. So V would be the negative integral of E dot dr. So if you're going to approach it this point of view, it's the area under the curve. I know that V outside of R is equal to, I think I stated explicitly, some old version of it, but yeah, let the potential be 0 an infinite distance away. So if that's distance, there's R. Outside, I know potential is a 1 over R relationship, because we've got spherical symmetry, so we can treat it as a point charge. So, sure, that's 1 over R. At this point right here, as I'm going this way, we start out with a lessening change. So if I'm going from here to here, my area under the curve starts out with much more change, and then less and less change as I go. So I would expect it to sort of flatten out the closer I get to the center. Also, that should be delta V. Or delta V is equal to the negative integral from infinity to some position R. E dot dr. I know that dr is pointing this way, same direction as my electric field, because it's a positively charged object. And so this is just the negative integral from infinity to r of E dr. If I'm outside of the radius of the sphere, then, so if R is bigger than big R, then it's just the integral from infinity to R of k q over r squared dr. And just in simple integral, you'll end up with the point charge formula for electric potential. If I'm inside, well, I do need to break my integral up into two parts. I have from infinity to big R, and then from big R to wherever R is. So if R is less than big R, it's going to be the integral from infinity to big R, kq over R squared dr, plus the negative integral from big R to little r, kq over, times whatever the electric field inside is. Now, I know it's a linear relationship because I've done it before, but the way, again, we are talking about a dielectric slash insulator. I only need to worry about the charge that's within that radius, because I know that any charge, because of spherical symmetry, any charge outside of the point in question is giving us an electric field of 0. So I have something with a uniform charge here. I know that the charge density is going to be the total charge divided by 4/3 pi big R cubed. That's the overall charge density. If I'm at a smaller distance, then I'll just use little q to represent that, over 4/3 pi little r cubed. So I know a relationship now between, so if I'm here, and we can go for this typical studying visual effects. So if I'm here, there's the center of the, I need to figure out what is the charge of this smaller sphere. Well, I'm calling it little q. Little q is equal to, well, those cancel out, those cancel out. It's going to be big Q times R over big R cubed. So that would be the charge that's within the radius. So my integral for the second part is from big R to little r of k big Q R cubed over R, little r over big R cubed over R squared. K is constant, big R is constant. That R squared cancels out with that cube related to this. Just stop me if I'm going too fast. Still good? So I'm left, and big Q is constant, and I'm left with just R. Lost an R somewhere. I lost a DR there. This is solving for potential difference, not the electric field. My electric field, kq over r squared. Little q, as we found, is that. So that becomes k over r squared, big Q, little r cubed over big R cubed, which is k cubed over r, big R cubed, r. So we get that linear relationship, that right there. So that would be the electric field if I have a uniform charge distribution throughout the volume of an insulator. That's the electric field at some distance r, with little r being less than big R, in essence. And so that's what would go in here for solving for the voltage. I feel like that didn't quite do it for you.
What would it's just a question about the graph of that.
All right. So we get there's some constant times R. The electric field is this is just a constant times R. When I plug into this part right here, when I'm actually solving for the voltage, this first part is just some number. The second part, you'll have negative K over R squared Q times 1/2 R squared. So that is just a constant. So my voltage is some constant, which is whatever the voltage is at the surface, plus this. Although I feel like a minus sign is off somewhere, but it's a negative, oh no, it works out. So as I go inside, it's parabolic because it's R squared, negative, so it's curved downwards. So curved downwards, the negative piece, quadratic, it's a quadratic part of a parabola. That's where that sort of gets stacked on.
Dr. Fox, is this master set 26?
Yes.
Okay.
Other questions about this?
And it was just C for forwards.
So now in part C, when you're asking about the work that must be done, I know that the electric potential at infinity is 0, because that's given. I find the electric potential at the point 16 centimeters from the center, so I'm outside the sphere. So I just find the potential there. I know that the change in potential energy is equal to Q times the change in the electric potential. So I have the charge, delta V, you will have found. And the question is this positive work or negative work? Well, it should come out of the math, but conceptually, I got a positive charge in the center. I'm bringing a positive charge closer to it. It wants to go away. So I need to push it. I would need to push it in the direction that I want it to go, because it naturally is not going to do that. So positive work or negative work?
Negative.
If you push in the direction of movement? Flashback. Work. It's a dot product. If force is in the direction of movement, then it's positive. If the force is constant, you're left with F dot delta S X, whatever letter you're using. Dot products are positive if there's some part in the direction of movement. So again, we have this particle starting infinite distance away and I want it here. Because it's positively charged and this is positively charged, they're going to repel. So I need to push it in that direction. I need to do work to get it there. So the work done would be positive.
Oh, it's not the work done by the particle, it's by...
What work must be done to bring it?
Okay.
Yeah.
The work done from the positive charge would be negative because it wants to...
Yes.
Okay, that's what I was thinking.
Yeah, what work must be done to bring a charge? Just make sure my interpretation. Oh wait, no, that's 4B. Here's 5. Oh. Yeah, also, if it's the positive. Other questions on this or others?
Is there any chance I could resubmit an updated version of this?
Yes.
How would I do that?
You can do it through Blackboard, right? I had that set up.
I already submitted it in Blackboard. I don't
Okay, you can resubmit. You have unlimited submissions
Oh,
in Blackboard. I have set it up so there should be unlimited. If it says, sorry, we're not gonna let you submit again, then that's my mistake. And what's gonna show up on my end, it will say, when I bring up your name, it'll say 1 of 2. And the first one I will assume is the lesser of the 2.
Can we take a picture of that?
Wait, see the picture? What?
No, can I take a picture of that?
Oh, sure.
Was there a place to submit a master's set?
I'd like to think there was. It might not have been there originally, it's been added since, or it could be that it was a fever dream of Patrick's that he was able to do it.
well, I might have emailed it.
Okay, that's also possible.
I know I've emailed twice, but I don't know if it was this one.
Yeah, I didn't see one.
All right. Then, I was just kidding about doing it through Blackboard. Okay, I'll try to remember to set it up. Other questions?